All right, welcome back. This is the second lesson of linear systems. This one we're going to start using algebra in order to solve our linear systems. So algebraic methods for solving linear systems give exact solutions. Solving by graphing can be used when an exact answer is not necessary because it can be hard to determine the exact value of an intersection when it doesn't occur at a nice location. So for example, if we have a grid and I'm graphing two lines on that grid, and let's suppose we have a scale, like 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. When we graph, sometimes that intersection might not appear at a nice location, like x value of 3. And we have to determine what is represented by this. Maybe it's 2.6, maybe it's 2.7, maybe it's 2.65. It's hard to tell because we're just using our eyes. We're not getting an exact location. If we went across, you might be able to tell that this one is a y value of 2, but the x value is difficult to determine. So that's why graphing is not always the best method, because it's hard to tell the difference between 2.5 and 2.6 and 2.7 because they're all so close on a grid. So that's where we have these algebra methods. We have two algebra methods that we're going to be using. Today we're going to be looking at solving by substitution. So basically what we're going to be doing is substituting one equation into the other. The next lesson that we'll look at is solving by elimination, but both are algebraic methods that allow us to find x and y without having to graph. So let's look at 1.2. Solving linear systems by substitution. The second method for solving linear systems by substitution is substitution. This procedure is, and it has all the steps listed. What we're going to do basically is choose one of the equations and isolate one of the variables. Then we're going to substitute that rearranged equation into the second equation. Then we're going to solve for the variable, substitute our answer back in and solve for the remaining variable, and then we can check to make sure we did it properly. So let's look at the two equations that we have. Question 1. Given this linear system, solve it graphically, and then we're going to solve it using the substitution method. So previously, we would have looked at this equation. We'll take the first one here, call it equation 1. This is y is equal to 5x minus 2. And I'm going to graph that. We know that the b value is negative 2. Put that onto my grid. We know that the m value is 5, or 5 over 1. So that means we're going to rise 5, 1, 2, 3, 4, 5, and run 1. 1, 2, 3, 4, 5, and run 1. And we can go in the opposite direction, and we end up with a straight line. Relatively straight line. That looks something like this. Then I'm going to take the second equation, 2, which is 2x plus y is equal to 5. And I'm going to try to graph that one. So in order to do that, we have to isolate y. So I'm going to take the 2x and move it to the right side. And I'm going to plot my new graph. I have a b value of 5, so that means I'm going to be starting on the y-axis at 5. Put a dot there. And we have an m value of negative 2, or negative 2 over 1. That's my slope. So that means I'm going to go down 2 and 1 to the right. Oops, down 2, 1 to the right. And continue that pattern all along. And we end up with our next line. So from there, we can determine what our solution is. I see our solution is right here at a point 1 and 3. So our solution is x is equal to 1, y is equal to 3. So we solved that one by graphing. That's what we did last time in 1.1. Now what we're going to do is our substitution method and show that we'll get the same answer and we don't have to worry about graphing. So I'm going to write the two equations down below. We're going to have y is equal to 5x minus 2. And we're going to have the second equation, which is 2x plus y is equal to 5. So the steps for this say, go back up, choose one of the equations and isolate one variable. Well, this equation over here already has one variable isolated, y. You can choose x or y to isolate, it doesn't matter which one. So this one already has y isolated. Next, we're going to substitute that rearranged equation into the second equation. So if all of this is equal to y, I'm going to substitute it into y. So I'm going to rewrite that second equation out, but I'm going to, in place of y, I'm going to put 5x minus 2. So I'm going to start, I'm going to say 2x plus, and then I'm going to put 5x minus 2 is equal to 5. So I'm just making a new equation that involves both of those. So I'll do that here. So we have 2x plus, well, y is no longer y. We now have 5x minus 2. That will used to be y is equal to 5. So that's that blue equation on the right. Y is no longer there. We substituted in the original, the first equation, into the second equation for y. Next it says, solve for the variable. So if you look at that purple equation that we have there, there's only one variable now, x, and I can solve for x. We can take the positive one, distribute it inside the bracket to remove the brackets. So I'm going to get 2x plus 5x minus 2 is equal to 5. I'm going to add my like terms together, and I'm going to bring the negative 2 to the right side. So first bring the negative 2 to the right side. It becomes positive 2. 5 plus 2. Add our like terms together. I'm going to get 7x is equal to 5 plus 2 is 7. And divide both sides by 7. We get x is equal to 1. So notice that's the same x that we had above. When we solved this one using graphing, I knew that x was 1, but now we solved it by substitution. Now I need to find out what y is. So the step for y was, take your answer that you know, and so step 4 there, substitute your answer back into the first equation and solve for the remaining variable. So I'm going to take that x is equal to 1, and I'm going to put it back, and use a different color. I'm going to take this x is equal to 1, because I know x is equal to 1, and I'm going to put it back into this equation here. And I'm going to say, well, y is equal to 5x, well, 5 times 1, because x is 1, take away 2. So I'll do that now. So that first equation was y is equal to 5x, well, I know x is 1, take away 2. And solve the rest of it through. Y is equal to 5 times 1, and y is equal to 3. And that's how we solve using the substitution method. Notice that's the same answer that we had above. X is 1, y is 3. That's the only answers for x and y that make both equations balance. So for another example here, we have a linear system where it might not be so easy to isolate one of the variables. We see that we have c here, D, C, and D. We say, which one of those do you think might be easiest to isolate? You might not always just pick the same one. So for example, in this case, I might say, well, I think this one would be easiest to isolate because I can just divide everything by 3. And we'll try that. I could have maybe said, let's isolate this one, 2D. We'll bring the 4C to the right side and divide everything by 2. That would be okay as well. We'll get the same answers. But we'll take the first one just because it's at the top. If I divide everything by 3, I'm going to have 3c is equal to 6d minus 12, and divide everything by 3. That creates my new equation, c is equal to 2d minus 4. And what I'm going to do with that is I'm going to take that value of c, 2d minus 4, and I'm going to substitute it in for c in the second equation. And I'm going to create a new equation in place of that. So it's a combination of both. One equation is substituted into the other. So I'm going to write that out. So that equation is 4. Then it's C. So I'm going to replace C with 2D minus 4 plus 2D is equal to 16. And now I have a super equation that has only one variable, D. So I'm going to distribute into each of the bracket here. So I'm going to get 8D minus 16, because 4 goes to both, if you remember, plus 2D is equal to 16. Now I'm going to get my like terms together. So I have the D values are going to stay on the left side. 16 is over here on the right, and it's going to be adjoined by another 16 because it's negative 16 coming over to the right side, so it's going to be plus 16. Add my like terms together. 10D is equal to 32. Then I can divide both sides by 10. And I get D is equal to 3.2 in this case. So you might notice that it doesn't work out to a nice whole number. 3.2 would be difficult to tell on a graph where it would be, but with substitution we get those exact values of 3.2. And finally, now that I found out D, I need to find out what C is. So I'm going to take my answer and I'm going to substitute it back in to the original equation, that one that we isolated earlier, because it was C is equal to 2D minus 4. I could actually substitute it into any. I can substitute in here or here in order to find out C, but this one's already isolated, so it makes things a little bit easier. C is equal to 2. We found out that D was 3.2 minus 4. C is equal to, multiply 2 times 3.2, which is 6.4. Take away 4, and we get C is equal to 2.4. A nice number. It's not a nice whole number. That would be difficult to tell where that is on the grid. Notice that the variables are a little bit different. C, D, X, Y, right? Could be cost and distance or something like that. But we're solving for two unknowns regardless whether what we call them, X or Y, or A, B, C, D. All right, we'll start looking at some word problems here. This one says Dylan works for a guaranteed pool repair. He charges $50 for a service call plus $40 for every hour that he works. Chris works for Oasis Pools and Spas and he charges $30 for the service call plus $45 for every hour that he works. Find the length of the service call where both charge the same amount. So I want to know for how many hours do they both work, will they charge the exact same amount? So we need to break down our two variables here. One of our variables is how many hours. And the other one is cost. So I should be able to make two equations using C and H as my variables. So let's take Dylan. Dylan charges $50 to come to his house, or for him to come to your house. Plus he charges $40 for every hour that he works. That's the equation for Dylan. So if he worked for 0 hours, the cost would be $50. If he worked for 1 hour, the cost would be $90, right? 50 plus 40. If he worked for 2 hours, the cost would be $130 because that's 50 plus 40 times 2 because you're paying that hourly fee twice. Chris works at Oasis Pool, so his cost is equal to $30, plus he charges a little bit more per hour, $45 per hour. So it's a little bit cheaper for him to, the flat fee for him just to come to your house. However, it costs a little bit more per hour that he works. So I want to know, when are they both the same? For how long would I need somebody to work where our cost would be the same and it wouldn't matter who I chose to work? So you're going to look at these and say, I need to solve for C and H. So you can say, I need to isolate one of the variables. Well, C is isolated here. It's also isolated here. So I'm going to take what C is equal to, and I'm going to substitute into the second equation for C. They're both isolated by themselves. So this one's going to work out to be a little bit similar. 40 plus, or 50 plus 40h. That's C, right? I replaced here. And we can continue on. Equals 30 plus 45h. Equals 30 plus 45h. And I'm going to try to solve that. Now, if you look at what we've got there, now we only have one variable, h. Oops. And now I need to get all my like terms onto one side. So I'm going to remove those brackets. Bring all my like terms to one side. So I'm going to have 50. 30 is coming to the left side, so I'm going to subtract, right? This one came over here to the left. On the right, we have 45h already, and I'm going to add another. Oh, subtract, because this 40h is coming to the right side. Subtract 40h. Add my like terms together, I'm going to get 20 is equal to 5h. And divide both sides by 5, I'm going to get h is equal to 4. So that means when these two guys work 4 hours, their cost will be the same. Now we say, well, what is the cost? So now I know h is 4. I'm going to put that back into one of the equations. It actually doesn't matter which one you put into. I'm going to choose the top one. Cost is equal to 50 plus 40 times 4. Total cost is 50 plus 160. Cost is equal to 210. So that means that if I have a job that requires 4 hours worth of work, both Dylan and Chris will charge $210. I can write my sentence. Dylan and Chris charge $210 for 4 hours of work. On either side of 4, one person's better, right? If you wanted a job that's 2 hours, well, one person will be cheaper. If you want a job for 6 hours, well, the other person will be cheaper. But for 4 hours, both of them charge the exact same amount. And that's what we found when we used our linear system. Just like all the other ones, we had 2 equations that we started with. We had to build them, but we had 2 equations we started with, and we're trying to solve for C and H. All right, last one here. Example 4. Last night, the St. John Paul II students staged a drama festival at the local theater. Student tickets were sold for $4 and adult tickets were sold for $12. All 300 seats were sold and the box office collected $3,024. Mark is the cashier. The manager wants to know how many tickets were sold at each price, but the cash register jammed and Mark had to sell tickets manually. He was so busy he was unable to keep track of sales. So what are our unknowns? Well, one of them will be student tickets sold. And we also have A, adult tickets sold. So let's make some equations. So if we read that first line, one thing that jumps out to me is it says, all 300 seats were sold. So how do I write an equation that says all of the A tickets plus all of the S tickets were 300? That's just total number of tickets. A plus S is equal to 300. So it might be 100 adult tickets and 200 student tickets. Or it might be 300 adult tickets and 0 student tickets. We don't know, but in total there were 300 of them. Next, we know prices. I know that student tickets were sold for $4, adult tickets were sold for $12, and we know the total amount. So I know that I can make an equation that says 4 times S. That means $4 times all the student tickets is the amount of money we earned from all the student tickets. Plus 12A is all the money we earned from adult tickets, right? If 100 adult seats were sold, well, 12 times 100 will tell me how much money we earned from adult tickets. And together, if I add up all the student tickets earned, the money earned, and all the money earned from adult tickets, we know that we earned $3,024. So those are our two equations that we're going to try to solve. So if we look at this one, we might say, well, which variable is easiest to isolate? So think about it for a second. Hopefully you said, well, either A or S, because I can isolate either of those just by moving the other variable to the other side. So let's do that. I'll isolate in this case A is equal to 300 minus S. I could have isolated S by having 300 minus A, but in the same thing. But the idea is I'm going to take what A is equal to and substitute it into the other equation for A to make that super equation. So I'll use a different color for that super equation. So I'm going to rewrite out that bottom equation, but when I get to A, I'm not going to write A, I'm going to write what A is equal to. 4S plus 12A. Well, what is A? It's 300 minus S is equal to 3024. And now I'm just going to distribute inside and solve for S. Notice that there's only one variable now. We don't have the two variables. That's what we did when we substituted one equation into the other, is we eliminated one of the variables. So when I multiply through, I'm going to get 4S plus, now 12 times 300, we have to distribute it inside. We're going to get 3,600 minus 12S, because 12 also has to go to that negative S. And that's equal to 3024. We're going to get all our like terms together. So 4S will stay on the left side, minus 12S will stay on the left side. We already have 3024 over here on the right side, 3,024. And I'm going to move 3,600 over here, and I'm going to have to subtract it. Then from there, we're going to add our like terms together. So I'm going to have 4 minus 12S, or 4S minus 12S is negative 8S. And over here on the right, we have 3,024 minus 3,600, and we get negative 576. And finally, we're going to divide both sides by negative 8, and we're going to find out that S is equal to 72. That tells me that 72S. So up at the top, S represents student tickets sold. So 72 tickets were sold that were student tickets. Now let's try to find out what the adult tickets were. Well, remember, we have that in red. Adult ticket is equal to 300 minus S. Well, I know S is 72 now. Adult ticket is equal to 300 minus 72. Adult was equal to, I put that in my calculator, and I get 228. That means 228 adults attended the show and 72 students attended the show. Therefore, student tickets were sold. And 228 adult tickets. And that's how we solve these. There's always going to be two variables. And you notice that the process is always the same. We isolate one variable. It doesn't matter which one. Typically, we're lazy, so we try to find the easiest one to isolate. And then we take what that variable is equal to and substitute into the second equation and solve that new super equation that we make. And that's solving by substitution. So any questions, be sure to let me know.